Hello, welcome to this short training video offered under the Smart Energy Solutions for Africa project, SESA. My name is Emmanuel Michael Biririza, energy specialist at the Urban Energy Solutions team of the UN Habitat here in Nairobi. In this short video, I will take you through the solar PV system sizing. So we'll be looking at what it is. We'll also understand the steps to size the basic solar home system so that to come up with the appropriate system size. So the sizing of the solar PV system is an art of determining what components to be used to be able to serve a particular load requirements. So it is very important to have an appropriate size so that to avoid the system size to be bigger than usual or even smaller than usual. And just as electrical bills at your home, that one home consumes different as compared to the other home. So there is no generic system size that fits all. So it's very specific from one user to the other. And so the steps of determining the PV sizing is you start by understanding the load requirements, which appliances that you are using. But then you select appropriate panel. You also do the battery size, and you select charge controller, and you design for the inverter. And as I explained in the previous video, so in order to be able to determine the size, you also need to know where are you going to install this system. So the number of sun hours in a particular location is very important in this case. So for example, in this video, I will take the example of one of the regions in Tanzania, which is Dodoma. So you can see from the table different locations with different installations. And in this case, we choose, the minimum, the month in which you have a minimum sun hours during a day. And this is May, where you have 5.38 sun hours in a particular day. So the first step to the design is to understand or to take a stock of the load requirements to be able to determine what energy you really need for a particular, for one day. And typically you use something like this in a table. So this example is like you have a kiosk which has these kind of needs. You have a TV set, decoder, lights, and you do a little bit of phone charging. So in the end, you have to enlist all the equipment and their characteristics in terms of wattage requirements and quantities, but also finally you have to also determine how long are you going to be using in each day. So finally you get the load requirements, which is a product of the wattage rating of the equipment and the hours in which you're operating in a particular day. So in this case, we have a total load of 160 watts and a load requirement, which is a product of time and total. And total load is 745 watt hours. So you'll have to remember this going forward because we'll be referring back in these figures. So the modular sizing, how do you do this? You need to, again, remember we took a location in Dodoma in Tanzania, and we remember the sun hours in that particular location. So the particular size of the module or panel, you have to take a total daily load requirements in watt hours, and you divide the total or the average installation, which is number of hours in which you have a peak peak sun. So if we take from our previous table, we get that number, but the number that you are getting, you have to take account of the potential losses. You know, the system has got different losses. If you run cables from one point to the next, you are encountering some resistance, and then you lose some electricity in between. So 25% loss is typically taken into consideration. And in this case, we get a module size of 184.64 watts. And you have to go to the market and see what is the next close number, which is the standard. In this case, we take 200 watts. And you also have to choose what is the size of the battery. You need to keep in mind the battery efficiency and how much discharge you are allowed to do in a particular battery. Of course, it differs from one to another, but most of the current battery, they have got the so-called allowable depth of discharge up to 80%, and you take the efficiency of 85%. And you have to also remember the so-called days of autonomy, which is number of days in which you assume there will be no sun, but still you also want to get energy out of your system. So the formula is you take the energy requirements, you multiply by the number of days in which you want the system to run, even if there's no sun, and then you divide by the depth of discharge and of course the system voltage. In this case, the system voltage is 12 volts, and we want our system to run even 2 days, despite if there's no any sun that is coming up. And in this case, you choose the next standard number, which is 120 ampere hour. And charge controller sizing has to consider whatever current that is flowing from the panel to the battery. And for example, our 200 watt module has got a short circuit current of 12 amps, and this is available in the data sheet, and of course is labeled in the back of the module. So you choose the nearest number. In this case, choose 15, so that to be able to have some buffer just in case there's some problems. And you have to choose inverter, and the inverter choice is taken from the total load of your system. And in this case, it's 160, assuming that you power everything at the same time. So the inverter has to be able to withstand whatever the load that you have. And of course, again, you have to also consider the efficiency of the inverter. And in this case, you have 188 watts. Again, you choose the nearest close number, which is 200 watts. And you also have to use appropriate cable sizes, because if you don't use the appropriate cable sizes, then you tend to encounter a lot of losses. Typically, we allow 5% voltage drop. And of course, there's a table which one has to identify appropriate cable sizes. But typically for small systems, connecting from panel to the controller, use 6 millimeter. And for 12 system, for 12 volt system, but for 24 you can use even 4 millimeter square. And for battery looping, and you use 10 mm square. And this is finally what you have in your system. You have a 200 watt solar panel or module of 12 volts, and charger controller, you put it 15 amps, and the battery capacity is 120 of 12 volts, and inverter again of 200 watts of 12 volts. So I urge you to also go through these additional materials that has been shown in this slide. I wish you all the best in perusing these materials, and I want to thank you very much.